So this is a video of a simplified version of the final exam assignment from SER 222. I'm going to do a brief list, and we can see that there are two Java files that you should get with the assignment. One is called bst.java, and the other is called randarray.java. In fact, you don't need to do anything with randarray. If I look inside that Java file, it's been completely implemented as a program that generates n random integers, but it allows values to be duplicated, which is going to be all right. The main function, public static void main here, will optionally pull in some arguments that are passed from the command line. The random seed, the number of items to generate, the minimum value, and the maximum value. If you pass in one value, it'll use that as the random seed. If you pass in two values, it'll use the second value as the length, three values and you get the min, four values and you also get the max. This uses this function called randarray, which is defined further up in the file. I did this in class. You may have forgotten. You might wish to review it. This generates a random array of integers. N is the number, low is the lowest value, high is the highest value. And it does it using a Java random number generator. It's declared up here as a static object. So if I save this and quit, I can compile that class using Java. And once it's compiled, if I run it, just by typing Java randarray, it produces as output a list of random numbers. It'll always produce that same list unless I give it a new seed. So if I pass in the value 12, it'll use that as the random seed. And whenever I pass in 12, it produces the same list of numbers. If I give it 13 as a seed, it produces a completely different list of random numbers. So depending on what seed I pass in, I can get a completely different list of random numbers. For some reason, they often seem to begin with 16. I don't know what that's about. Just a quirk of the Java random number generator. There we go, one that began with 15. So there we can see that we can generate random numbers. And the other assignment is a BST assignment, so bst.java. This is one where I actually expect you to write some code. If we look inside bst.java, you can see that it's actually got some to-do items for you. So you're going to not completely implement a BST. You're going to write a node class for a BST, which is going to hold as data an integer. And of course, it's a binary search tree, so you're going to need references to the node to your left and to your right, and so forth. And then this class has a static public method called buildTree, which takes in a list of integers called a. And it should return the root of a tree as a node. So that root, of course, has left and right children and so forth, and it's the root of a binary search tree. So all the nodes are ordered properly, as a binary search tree should be. Then this class provides, and you need to implement that, of course. Then it provides a pre-order function, also a static function here, which takes as input the root of binary search trees and an array list of integers called results. This is typically going to be empty when it's passed in, and what your function is going to do is it's going to recursively visit all of the nodes of the tree using a pre-order traversal, and for each node it's going to add the data associated with that node to the results. It's going to keep adding to the end of results, so that in the end, results is an array of integers as they would be encountered during a pre-order traversal of the tree. In order works exactly the same way. It accepts a root node and an array list of integers, and it appends every integer in the tree in the order that it is encountered during an in-order traversal. And post-order will print all of the integers. It'll add them all to the results array list in the order that it's encountered in a post-order traversal. So all of those you should know pretty well. For a binary search tree, your sanity check here is the length of result should be the same as the number of items in the list used to build the tree. And all of the items in pre-order, your root of your binary search tree should be first. So you should know those rules. I shouldn't have to explain them. That's part of the idea of this being a test of your ability to understand these things. Level order is something that may not be obvious. I gave this as a separate file when I did the final. The idea is that if the binary tree was full, this would print it kind of in level order, the same way that a heap would be printed, for instance, except for that this isn't a heap. So the idea here is you're essentially doing a breadth first search. The first thing that would be printed is the root of the tree, and then every node which is on the next level, so the root is level 0, every node on level 1 should be printed from left to right. And then every node that's on level 2 should be printed from left to right. And so on until you've printed every node in the tree. So it's sort of a breadth first search, taking care that all of the nodes on each level are printed from left to right. So an ordinary, if you just followed the breadth first search pseudocode, it wouldn't work perfectly. This may require some thought. And then I provide some wrapper functions. So these ones don't have any to-do comments for you. This pre-order function that doesn't take an array list as an argument, but instead it returns an array list. What it does is it creates an empty list, calls the recursive function which you should implement, and then returns the result. So this is sort of like the simpler interface to pre-order. Same for in-order, post-order, and level order. So hopefully those make sense. Each one of those 4 functions takes your binary search tree and builds an array list of integers, and each array list of integers will be in a slightly different order. And then we have the function main, which is designed so that it could be interactive, or you could redirect a file into it for testing. It prints to the user that this is a test program, enter numbers and separate them by white space, and press Control-D on a Mac at least. That ends the file. It might be something different on Windows. And the program will print the numbers in pre-order, in-order, and post-order, and also I should add this and level order. So it's going to print them in each order. The way the program main proceeds is it creates a list of numbers, and it scans the standard input. As long as there's another integer on input, it adds that integer to this list of numbers until it hits the end of input, which is Control-D. Then it uses the build tree function, which you'd have implemented earlier, to get the root of a binary search tree that has all of those numbers in it. Then we print the word pre-order, and we iterate. So this is a for each loop that iterates through all of the items returned in the pre-order array list. So this calls the function pre-order, which returns an array list of numbers, and this iterates through all those numbers, and it prints a space followed by the number. Right? Similarly, in order, it uses the in order function to get an array list of integers that are the result of the in-order traversal, and it prints them out all on one line, ending with a new line. And post order, it calls the post order function, prints them all out on one line, and then it prints a new line. And level order calls the level order function, which returns an array list, prints them all on one line followed by a new line. So that's the entire program. You need to implement the to-do parts. As I give it to you, it should compile without any warnings or errors, but the output won't be correct. If I were to run bst.java, not BST, I just run BST, it shows me the output. This is the BST program, enter numbers, and I'm going to do a reasonable test would be to use the tree that you get from your keypad. So maybe start by printing 5, which would be maybe the root of a tree, then 3, then 7, then 4, then 6, then 2, then 8, then 1, then 9. So there's a list of numbers, and when you're done, I've put those in. I'm going to press Control D, and it should print them in pre-order, post-order, and level order. We can work out what those values should be. So if I can create a little file here, vim test1.in, and I'll just put those numbers that I typed before into a file. So I did 5, 3, 7, 4, 6, 2, 8, 1, 9. So those are a tree made with numbers on the number pad, and I will write it. And if I run BST and I pipe in test1.in, I see an example of the output. So let's talk about what the expected results should be. Let me turn off syntax highlighting. I think it's got spell checking enabled. So I got it. So sorry I had to do that little bit of a lookup. It should be easy to read this now. So this is the output of the program. In pre-order, remembering that the tree was, let me try to do a new tab. Test1.in. So test1, this was the tree, 5, it's the numbers, 5, 3, 7, 4, 6, 1, 9. We could think about what the tree should look like. So let me kind of make a new tab to kind of draw the tree. So it should have, it should insert a 5 into the tree. And then to the left of that 5, it's going to insert a 3. And then to the right of the 5, it should insert the 7. And the next thing I did after that was I believe I inserted a 4, which should end up over here to the right of the 3. And then a 6. And then after that, I inserted a 2. And I inserted an 8, and then after that I inserted a 1, and I inserted a 9. So this is what the tree should look like with the nodes approximately positioned as the tree would be. 2 is the left child of 3, and 4 is the right child of 3. So with this tree, a pre-order traversal would start at the root, and then it would print the left subtree, Again, starting at the root and then printing the left subtree. Again, starting at the root and printing the tree. Then it would print the right subtree, and then we're back up to 5. So at the tree starting with 7, it prints the root, then the left subtree, which has a 6. Then it goes back and it prints the right subtree, which it starts with an 8 and 9. So that would be what we expect for pre-order. And you should hopefully check me. In order, it should do, starting with the root, it should go left. It should really print the tree in the order we see these notes. It should be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's what we expect for an in-order traversal. And post-order, it should print the root, obviously, last. The first thing it's going to do is it's going to print a 1, and then it's going to print its parent at 2. It's going to print its sibling, which is a 4, and then their parent, which is a 3. So we've done that left subtree. For the right subtree, starting at 7, it's going to print the left thing 6. Then it's going to print its sibling 8. No, it's not going to print its sibling 8. It's going to print the tree starting with its sibling 8. It has a child 9, and then the 8, then the 7, and then the 5. We can do the sanity check for every single subtree. Its root should be the last thing. So 5 should be last. For this subtree up here, 7, 6, 8, 9, 7, 6, 9, 8, 7. So they occur with that order with the root last. For this little tree with a 9 and an 8, the 8 should be last. There we go. They both come before the 7. So you can kind of see that for every subtree, the parent comes after the children. So that's a good post-order traversal. And here's the one that may be confusing you guys, level order. So what do I expect for level order? I expect it to print 5, 3, and 7 in that order, and then 2, 4, 6, 8 in that order, and then 1 and 9 in that order. So you can see each level is printed after the previous level, and every node on the level is printed from left to right. So we can take this and put those into the other file. So this is what the program would output if it was implemented correctly. Pre-order, the root comes first. In order, the nodes would end up in a proper binary search tree being printed in sorted order with the root in the middle. In post-order, the root comes last. And in level order, each level of the tree occurs from left to right. So the first level is 5, then 3 and 7, and 2, 4, 6, 8. And then at the last level, you have a 1 way on the left and a 9 way on the right. So I can WQ and go ahead and quit this. And I've given you an example of an input file. This should be everything you need to give your code a sanity test and implement it. So good luck.